Okay, lovely. So welcome to our very first geometry class. This is actually the first time we've run this session. So this is definitely going to be like a trial and error kind of thing. But we are really, really excited to be here and offering these new classes for you guys, especially at the start of the year. So I like to start off all these classes with a little bit of an icebreaker so that way we can get to know people in our classes, hopefully make some new friends. And this isn't just math. So, for today, because this is our first time meeting all of each other, I want to find out where are you guys from? We've recently started expanding a little bit outside of Georgia, so I'm really curious to see what some of these other states are. For now, let us know where you are from, where you come from, and yeah. Okay, awesome. So, let's see. We have Manit from Cumming. Awesome. So that's a little part in Georgia. Uh, Amari from Stone Mountain, Georgia. That's awesome. I actually have a friend who's from near there as well. She's really cool. She's really good at singing. Awesome. I used to visit Stone Mountain all the time as a kid, so it's a really nice place, in my opinion. All right, Vaidehi is from India, who then moved to New York, and then Atlanta, and then coming. That is so, so cool. Wow. Vishith was born in Delaware and then moved to Ohio and then moved to Cumming. That's awesome. Aditya says Cumming, Georgia. Syed says Oregon. Wow, that's really cool. Sai Praneeth says I'm from India and then came to Cumming, Georgia. Awesome. Zia says I'm in Georgia. Awesome. Ooh, best in the world. I wonder who that is. But they are from Atlanta, which is very cool. Let me put Atlanta on here. Yoonjan is from Coming as well. Awesome. Aradhya is from Coming. Cool, cool, cool. Hitarth is from Georgia. Actually, let me put Georgia the state as well. That's like important because I think that's where a lot of people are from. Adyak says Philadelphia, but I moved to Georgia. Very cool. That's awesome. Nahal says from North Carolina. That's awesome. Yeah, so for those of you guys who are maybe joining us for the very first time at Bridge to Math, we actually started, so this is our second year running classes and things, and we started our very first class of the year on Wednesday, and that was our Advanced Algebra and Number Theory course. So I use the same icebreaker because I like to see where everyone is coming from, see how we're all joining and things, and there we got a lot of people from all over the world, which I think is really, really cool. So yeah, definitely very interesting to see how we are all connected through the internet and we can all do math together. I think that's awesome. Okay, I see a couple more people are joining us, which is great. For those of us, or for those of you guys who are newly joining, go ahead and let me know where you are from, where you are joining us from today. And yeah, that would be awesome. And then I'll go ahead and introduce myself maybe in a couple minutes, and then also give you guys a little bit of background on this course. And then we'll jump right in. Okay, awesome. If you guys also want to like put what grade you're in too, that would be really cool. Oh, Adyak has a question. Yeah, go ahead. What's your question, Adyak? Oh, where am I from? Yes, I will reveal this mysterious question. Yeah, I will reveal where I am from, Adyak, in a second. But let's look now at grades. Okay, cool. So Manit is in fifth grade. Awesome. Arjun. Oh, Arjun is from India. Very cool. And he is from sixth grade. Cool, cool, cool. Zia is in sixth grade. Awesome. Sai Praneeth is in sixth grade. Aravya is in fourth. Nihal is from sixth. Amari is sixth. Vishit is sixth. Hitarth is seventh. Awesome, awesome. Vaivehi is in sixth. Jason is sixth. Wow. Arena is sixth. Wow. Oh my gosh, we have so many sixth graders here. That is awesome. Atul is sixth. Aditya is fifth. Oh, Amari is seventh. Okay, cool, cool. Yeah, I know we're still in that like awkward, like about to enter school phase, and it's like I'm a rising like seventh grader, but I also feel like a sixth grader still. So totally cool. Um, but yeah, this is awesome. So, some of you guys have probably been exposed to a little bit of geometry, but maybe not everything that we're going to see in this course, which is good. That means you guys are going to learn new things, which is exactly what we want to happen. Okay, awesome. So I think now is a good time to transition a little bit. So I'm going to go ahead and introduce myself first. My name is Sam. I'm the founder of Bridge to Math, and I am one of the head instructors here. So I have been teaching most of these classes. If you've been with Bridge to Math before, you've definitely seen my face or maybe got an email from me or something. If this is your first time here, welcome. We are so excited to have you. And yeah, so these classes are definitely a little different from classes that you've done before in that there will be a lot of student participation. So I hope to see a lot of answers from you guys in the chat or questions, anything you have. Don't hesitate to ask or share. We do try to make an open space here so that everyone feels comfortable. And yes, there will be a lot of student participation. So sometimes I'll call on students to answer things, maybe give ideas. So uh, don't be shy. No one is going to criticize you here. So definitely go ahead and share something if you want to. Yeah. Okay. So a little bit. Oh, and also, I have been doing math for quite a number of years. I started competition math in third grade. I did mathleague.org throughout my elementary schools and into my middle school years. And I qualified to nationals for multiple times, placed second in fifth grade at nationals. So definitely have a little bit of that mathleague.org background. If you guys have done mathleague.org, I know a lot of Bridge to Math students do this competition. Let me know in chat. I think this is super cool. And then, yeah, now I am a senior at Lambert, and I still do a lot of math. I compete with our math team, definitely do a lot of tournaments and take some fun classes at school, like calculus and linear algebra and fun things like that. So definitely a really cool class. Lots of math things going on. Okay, awesome. So it seems like quite a few students have done Math League, which is awesome. So very cool, Aditya and Arabia and Atul and wow, Monique got fourth place in fourth grade during Math League Nationals. That is awesome. But I bet he placed fifth in fifth grade. That is so cool. Wow. Oh, Zia did Math League too. Okay, this is awesome. If you guys like what we're doing here today, I highly recommend you go check out mathleague.org. They do a lot of really great competitions. Especially a lot of you guys who are in Georgia, they are definitely very big here. So I would definitely go check it out. Okay, awesome. Oh, some people are talking about the homework from a different class, which is very cool. If you guys are stuck on that though, don't hesitate to email in regards to that. Okay, awesome. So a little bit about this class. Like I said, this is the first time we have done a geometry class, so I am very excited about this. Hithart says, I don't like geometry. It's my least favorite. Hopefully this class will change that. Geometry can definitely be challenging. I know this is something that I used to struggle with a lot, and sometimes it's actually still a little hard for me. But with understanding like some very important principles of geometry, which we'll talk about through all of our classes throughout the semester, hopefully this will be more exciting and a little more approachable. So, with that, for first class for today is just going to start off with some very basic concepts, introducing points and lines, and then transitioning into angles. So hopefully this is all stuff you guys have seen before. We're going to formalize a couple of definitions here, and then we're going to go from there. So very good foundation for today. If you're challenged at any point, drop a question, and hopefully we can clarify for you. Okay, I think we have done enough talking. Let's go ahead and get started. Let's do some math now. All right. So, in geometry, geometry is basically founded upon understanding points, lines, planes, angles, like all of this stuff, no matter what level of geometry you're doing, is relevant. So that's why we're going to spend a good chunk of today discussing this. So first, let's go ahead and do some definitions. So, can anyone define what a point is? Like, what is a point? What is a point? Okay, Manit says a dot. Awesome. Let's see. Ooh, Hitharth also says a dot. Vivek, he says a dot. Zia says a dot. Wow. Okay. Is a point equal to a dot? Let's see. Oh, Cypherneath gives a little bit more of a precise definition. A dot showing a place. Interesting. Aditya says a place on a plane. Okay, so pretty similar, like to showing maybe some location or something. Oh, Vivek, he adds a dot on a coordinate plane. Okay, awesome. Oh, Ambika says a 1D singular point on a plane. Wow, I like how very technical we're getting. This is very interesting. Cool. Ooh, Amari says a dot showing a place in a series of a plane. Okay, awesome. So it seems like we started at a dot and then we've kind of evolved to like something that shows a place. Shows a place, which is essentially correct. So a point is basically just any location in space. Something important about a point is that it has no size. It just has a position. So if my dot looks like this, and it represents a location, that is actually the same as a dot that looks like this. So even though they're different sizes, they are both still points. They are both points, but they represent different places on the plane. Actually, I am really glad that I have this whiteboard with a grid now, because this is going to make a lot of our plane discussions easier. Yes, Hithard says, I don't like the first dot, which is good because that first dot is gigantic and you don't really want to draw dots like that in your diagrams. Like Cypherny says, it's more of a filled circle than a dot. Okay, so a dot points are normally marked by like a dot and then also a capital letter. So if I drew, for example, this point over here, we'll say this is point A. Normally you won't write point, you'll just write A, but I'm trying to make a point. Pun not intended. Okay, so let's move on. Let's take it up a notch. So this is 1D. I think he said this is 1D, I believe. Someone said it was no, it was Anvika. Anvika said this is 1D, which I really like. That's really important. So let's take it up a notch. Let's now talk about a line. What is a line? Some of you guys might be like, why is she making us define all these things that are pretty simple that I understand? That's because understanding these definitions can be important because you will sometimes get tricked by just a small misunderstanding in definition, which is why it's really important to precisely define like some of these geometric things. Okay. Wow, Hithard says a line is a line. Yeah, so this kind of shows like it's kind of difficult to describe like what a line is, right? We understand it, we know what a line is, but it's hard to like put it in words. Okay, Vibeki says a line extends infinitely. I like this idea of infinity. I think that's good. Hithard says a one-dimensional object. Okay, interesting. Cypernite says a line is a straight that goes on forever. Okay, I like how we've added the adjective of straight. I think that's important. Vishith also agrees that it's never ending, so kind of going to infinity. Amari says a line is a line that extends infinitely on a plane. Okay, remember definitions cannot use the word itself, so I can't say a line is a line. I gotta give a little bit more depth to that. So this is like really getting into the roots, right? Like how do we define something that we understand so very like easily? Like we know what a line is, but how do we put it into words? So Envika says a line that carries on both sides forever on a plane, and it is two-dimensional. Okay. Oh, it is one-dimensional. Okay, okay. A one-dimensional geometric figure that extends infinitely in both directions. Okay, that's from Arjun. Awesome. Manit says a line is a thing that you draw shapes with. Okay, I like that. That's true. You can build a lot of things with a line. Oh, Nihal says one end of the ray is ending and the other is going on forever. Okay, so we're bringing in a little bit of a new terminology here, which is interesting for sure. We haven't defined array yet, so I'm gonna hold off from there. Okay, cool. So I think we got quite a few answers. So, and it seems like you guys are really getting to the main idea here. A line is straight, that's true. A line is also infinite. A line goes on forever. So formally, a line is a straight path that extends infinitely in both directions. So that's also a really important thing. It goes in both directions. If it's infinite, there is no stop and end. So truly, direction actually doesn't matter. It just goes on forever. A line is also named by 2 points. So a line will connect two different points. So that's why it is going to be one-dimensional. So 2 points. So I think Anvika said a point is zero-dimensional and a line is one-dimensional, which is perfect. So some people are mentioning this idea of rays. I think Amari said it, and then Nahal said it. Yeah, yeah. So a couple people have mentioned rays. Oh, Arjun also said ray. Okay, awesome. And Cypernate, great. So let's talk about a ray. So a ray is very similar to a line, except instead of going infinitely in both directions, it goes infinitely in one direction. So you can think of a ray as kind of like an arrow. And let's write that down here. So a ray is equal to an arrow, essentially. So it's infinite still. So it's infinite, but in one direction. Okay, so it is still very similar to a line, except it's just not infinite in both directions. So an array is just a really, really long arrow. Okay, very nice. So we've covered zero dimensional, we've covered one dimensional. Let's take it up a notch and look at two dimensional. So, can you guys define a plane? Now, I don't mean like an airplane that flies in the sky. I mean the geometric plane. So, what is a plane? Oh, it seems like we're a little challenged with this one. That's totally okay. I think I gave a good part of it away because I said it's two-dimensional, which is a big chunk of the definition. Let's see if maybe we can get some extra stuff. Okay, Amari says it's a grid using locations. Bishop says it is a plane in two dimensions. Sai Praneeth says a plane is a location on a grid. Okay. Mini says it's a side. Okay, interesting. Akshin says it's a square with four segments. Awesome, awesome. Okay, so I think a lot of you guys are thinking of a plane as like a rectangular thing. Like maybe you're thinking of like this sheet of paper. Maybe you're saying, "Oh, this sheet of paper, this is a plane." And that is true. Paper is a plane, but it's not the most accurate definition of a plane. There's a couple more things that we need to include to decide that something is a plane. I'm going to help you guys a little bit out here. So remember a line, we can get to a line by just putting a bunch of points together, like really, really close. Put a bunch of points together, string it up, and you get a line. You have your points going infinitely. So that's a line. That's how we get from point to line. Now think about how we can get from line to plane. I said a point is an infinite number, or a line is an infinite number of points. So by that reasoning, maybe a plane is an infinite number of lines. What do you guys think about that? Does that kind of make sense? Or is that super weird? What do you guys think? Oh, okay. It seems like Tanish is kind of like on the same thread. It's a flat surface with joins lines. Yeah. Okay. Awesome. Awesome. Okay, so it kind of makes sense. Yeah, so this is like very intuitive. It's definitely very like theoretical. So, and it's hard for me to draw too, just because I can't put all these lines like squished up together. So actually, let's bring out this like nice sheet of paper again that I have conveniently sitting next to me. So I'm gonna take this piece of paper. All right, and what I'm gonna do is I'm gonna take some scissors and I'm gonna cut it into really, really, really thin strips. Remember, a line has a length. It goes in directions, but it has no width, right? It's super, super thin. So I'm gonna cut this paper up into super, super thin lines. If I had a scissor, I would, but I don't. And that's gonna give me an infinite number of lines. So do you guys kind of see how a plane can be formed from lines? Does that kind of make sense? Okay, okay. I think we're like kind of getting it, which is good. Okay, this is awesome. So yeah, a plane is basically, yeah, I'm not gonna rip the paper. It's a nice, very blank sheet of paper, so I'm definitely gonna use that for something. Yeah, so a plane is basically just a flat surface. And something important about a plane is that it's actually infinite. So that is infinite. Okay, so I know a lot of you guys were saying, "Oh, planes are square; they're bounded by four sides." But actually, planes go on forever. They have no end. We like to think that planes are bounded by something because we normally think of a plane as a grid, and grids come in like squares or boxes. But actually, a plane goes on forever. It is infinite. So yeah, lines and planes are infinite, which is pretty important. Actually, a plane also doesn't have to be square. Technically, this blob is also a plane because it is a flat surface and it is infinite. So this can be a plane, which is very odd. You might think that is a little counterintuitive. You won't really deal with stuff like this. A plane is mostly just important because we need to understand, especially in three dimensionals, what is a plane. So that's why we're introducing it here. Okay, you must be like, wow, I have never gone this deep into lines and planes. We are almost done with this section. If this is not your jam, which is totally cool, we just have one more thing to cover, which is a line segment. So we talked about lines, and we said lines are infinite. But you guys have drawn a line before, and obviously you are still here, and you have probably finished drawing your line. That's because we don't draw lines the infinite way. We draw line segments, meaning we draw a portion of the line. So a line segment is literally just a part of a line with two endpoints. When you draw lines, you're actually drawing line segments. But sometimes the problem will say, oh, there's this line that cuts through the shape, and they're talking about a line that goes infinitely. So just that little distinction is a little important. Oh, Sai Praneeth asks, can a rhombus be a plane? That is correct. Yeah, a rhombus can be a plane as long as it goes on forever. So it's like an infinity rhombus. But then I guess you can't really tell, is it a rhombus, right, if it goes on forever? So a little bit of a dilemma there. Awesome. Yeah, like Sai Praneeth says, a line segment is just a line that stops. Amari also says a line connected by two sections. Yeah, that's a line segment. That's absolutely right. Arjun says a part of a line with two defined endpoints. Yes, I really like that. And Arav says a similar definition. Okay, awesome. So I'll put line, actually, let's write this. Okay, if you guys do take notes, I mean, I have no preference on whether you guys take notes. I think it helps for some people, it doesn't help for others. But if you are, I would recommend writing this somewhere, just because this is a little important, in my opinion. Okay, so a line segment is a line that stops. I think this is my favorite definition. All right, so I'm gonna leave this up for a few seconds, give you guys a couple seconds to digest, a couple moments to digest. And if you have questions, something is whack to you, shoot me a message. And if you don't want to shoot me a message like publicly, you can shoot me a DM. Okay. I want to kind of jump back to points really quick. So we talked about points and lines. Oh, what grade would this be taught in? When I learned this, I think it was like in eighth grade math, so eighth grade curriculum. So this is definitely above most of you guys, yeah. So if this is challenging, it's okay. Do not fear. Please ask questions. Okay. All right. So a couple of things about points. There's some special classifications for points. We have things called collinear points. And collinear, you can kind of break this up to understand what it means. It's basically you have co means together, and linear means a line. So we have points together on a line. So this is points on a same line. Okay, awesome. And then similarly, we also have coplanar points. So you can kind of break this up once again. This is points that are together on the same plane. So points on same plane. Okay, lovely. A couple of things about drawings and stuff. So if this is like, oh my God, why are we writing so many words in math? This writing is gonna go away now. So I'm gonna make this go away. Okay, lovely. Now we can actually do some numbers and diagrams and things. Okay, just a couple of things with notation. This is a line. Okay, this is a line. Notice how, actually, before I say anything, this is a line segment. Okay, what is the difference between these two pictures? Spot the difference. A quick game of spot the difference. Arjun says line is longer. Vabehi says one never ends. The line segment ends. A line continues endlessly. Line segment is okay. So it seems like a lot of you guys are kind of on the right track. I mean very literally, like what is different between these pictures. So one goes on forever. That's true. That's a line segment. And the way we know it goes on forever, that this is specifically a line segment, is because of these arrows on the end. That means that they just go on forever and ever and ever. But a line segment, in contrast, will have these dots on the end, meaning it stops, it ends. That's where it's gone. So to get a ray is something that starts at one point and goes on forever in another direction. It's an arrow, just a gigantic arrow, really. So a ray will be represented by a point on one end going on forever and an arrow on this other end. So kind of like this. All right, so just a small notation thing. If you are kind of taking this class for like school math purposes, this is something that definitely is a little important. Okay, yay, this is probably not the most exciting thing, but it is important, so I'm glad you guys stuck with me. Now things will get a little more exciting and hopefully more fun. This is gonna be Angles. All right, I think angles are really cool. We can do a lot of fun stuff. And today we will actually be doing some angle chasing. If you don't know what that is, that's a-okay. We will talk about it. So yeah, I'm pretty sure you guys are familiar with an angle is, but let's define it really quick. So an angle is just formed by two rays that have a common endpoint. So let's draw this out really quick. Let's use blue. I feel like I haven't used blue yet. Okay, so this is my common point. This is one ray, and this is another ray, and this is my angle. So we'll represent angles by like little arcs between the two lines. So that's it. Very simple. Yeah, Cypress says an angle can be measured by degrees. That is absolutely correct. Oh, Arjun says an angle is three or more points that lay on the same straight line. I don't think I agree with that definition. I don't think, yeah, I'm not sure I entirely agree with that definition because in this case, we have two rays making up the angle. It's when two rays meet, that's when an angle exists. You can't have one line and an angle. Okay, cool. So let's define a couple of angles. I think you guys are pretty good with this kind of stuff, so I'll just ask you as a quick review, and then we'll go from there. So, oh, actually, I guess this is a little important, so I'll put it here. Okay, can you guys define an acute angle for me, please? What is an acute angle? Yeah, it's less than 90. Actually, I'll have to draw the arrow sign. So 90 degrees. We don't really use radians much unless we're dealing with circles. So for all intents and purposes, I am saying degrees. Awesome. Okay, what is a right angle? Yep, exactly 90. Perfect. What about an obtuse angle? Uh, Greater than 90. Very good. Greater than 90. And what about a straight angle? What is a straight angle? Yeah, it's just exactly 180 degrees. That is absolutely correct, you guys. Yeah, a straight angle is just a line. And you can kind of see this by looking at it like this. So it's two rays that are joined exactly end to end but point in opposite direction. So that is a line. Very cool. Okay, so I was gonna ask you guys to classify angles, but that seems kind of silly because this is like very intuitive and you guys are very good at this. Okay, I do see a lot of spam. Not a lot of spam, but I do see some kind of comments that are not entirely related to what we're doing. So if we can minimize that, that would be great, just so that I can see who needs help, like who's asking questions or who's putting in some ideas in chat that I want to highlight. So thank you guys. So very appreciated. All right, and then one final angle actually that I want to highlight is the reflex angle. Yes, oh my gosh, Nahal, you just read my mind. That is awesome. I was literally about to say that. Wow, that's really great. So, does anyone know what a reflex angle is? Okay, Viveki says 360, Aditya says 180, Cypherneet says 360. Okay, so I'm gonna kind of put you guys away from this path. It's not a number. A reflex angle is not a specific number like a straight angle or a right angle. Oh, okay. So I'm starting to see people kind of in the right path now. Some people are saying Nahal, Arav, Manit, Vaivehi. Okay, Hitharth. Okay, wonderful. Syed, awesome. It's stuff that's greater than 180, but less than 360. So all of you guys have said that. Great job. That is absolutely correct. We don't really deal with angles like greater than 360, so I'm just gonna say greater than 180 degrees. That is absolutely correct. So a reflex angle looks kind of like this. So normally we'll say this is the angle we're looking at, and this would be obtuse. But a reflex angle is this thing. Let's see, maybe I should do a different color. The reflex angle is what's gonna be in, let's do orange. Okay, this is the reflex angle in orange. Okay, so just a little distinction there. Tanish says smaller than a full circle, but greater than a line. Absolutely correct. Okay, great. So you guys are great with that. I don't want to spend too much time on that. So let's move on to something else. Let's talk about complementary angles. So, what are complementary angles? What do you guys think? Oh, okay. One thing that I see, Cypernete says, is a reflex angle like a flipped right angle. It can be, but that's not the formal definition. So you can have a reflex angle Yeah, it's like a flipped acute angle, but as you can see here, like we can have an obtuse angle as well, and then a reflex angle with that. So as long as the reflex angle is greater than 180, that's all that matters. So reflex angles are just like really gigantic. They look more than a line. But yeah. Okay, awesome. So looking to okay, so now we're talking about complementary angles. All right. Um, I think let's change colors. Let's do a dark green. Okay. Complementary angles. All right. So sorry, I like diverted from you guys. So I don't know what a lot of people saying. I think I'm seeing a little bit of division here. I'm seeing two angles that add up to 180, and I'm also seeing two angles that add up to um 90. Okay, so we seem like we have a little division here. There's no proof for anything major for this. It's just a definition. So complementary angles are two angles he measures sum to 90 degrees. So sum of angles is 90. And the way I like to remember this is because complementary starts with like CO, like corner, and corners are 90 degrees. So hopefully that is a nice way to help you remember that. And then on the other side of complementary angles, we have supplementary angles, which I will use this brown, I guess. I'm using brown now. Okay, supplementary. Wait, I can't spell. Okay, there we go. And now I can spell. Spelling is hard. Okay, so for those of you that maybe guessed complementary wrong, what is a supplementary angles? What are supplementary angles? Yes. Okay, I'm seeing some answers. Let's see if we have some consensus here. Let's see if anyone agrees. Okay, cool. Yeah. So Nahal, Tanish, Syed, Arjun, Jason, awesome, are all saying that the sum of the angles is 180, which is absolutely correct. The way I like to remember this is supplementary starts with an S, that's kind of like a straight line, and a straight line adds up to 180 degrees. Okay, very cool. So not super complex, it's just a good definition thing. But supplementary and complementary angles are going to be a really important tool for angle chasing. So it's important that we understand this definition. Okay, awesome. I think I'm going to clear up these angle classifications and make some more space for our other stuff, just because we are kind of advancing in the content now. Okay, cool. No, I did minimize things that I wanted to keep. Oh no. Okay, this should be good. All right, so our skin is a little clear. Let's move this up here. All right, so let's now talk about vertical angles. Who knows what vertical angles are? Let's pick a more bright color to talk about this. I think we should do some red. Arjun says, do we use protractors? Not in this class. To be honest with you, past third grade where you are required to use a protractor because it's in the curriculum, maybe eighth grade actually, I don't know. You don't really use protractors anymore. No one really asks you to measure angles, so don't worry about protractors. Okay, vertical angle. Wow, these colors are clashing so bad. I apologize to you guys. I just randomly pick colors. Maybe next time I'll like let you guys pick the colors. Okay. Okay, Manit says angles that are vertical. Well, that is very helpful. Yeah, beyond that, what is a vertical angle? Okay, Tanish says non-adjacent lines forming an intersection. Okay, yeah, kind of close. They have to be opposite. Okay, yeah, this is good. I like this. Does anyone else agree with this? Have any critiques? Anything they want to add? Minnie, your answer is not wrong. It's just maybe not helpful for defining vertical angles, which is okay. Okay. But Becky says maybe blue for the next color. Okay, yes, I will keep that in mind. I will use a blue. All right, Vishith says opposite angle is when two lines intersect. Okay, cool. Now Hall says a straight angle, and I'm gonna kind of disagree with this. Something important for vertical angles is that they have to occur at an intersection, which is what a lot of people are saying, which is good. So you can't just have like a line. There is no vertical angle if you just have a line. That is a line. Yes, okay. Okay, cool. So it seems like we're really approaching the right definition here. So vertical angles are opposite angles when two lines intersect. So at an intersection. Okay, and these are always equal. You can actually prove this. We don't have the tools yet to do so, so I'm not gonna explain why it is now. Or no, actually, no, we do have the tools. Wait, wait, wait. I am lying. I'm thinking about something else. All right, yes, we can totally prove this. Okay, so let's actually draw a quick diagram here. Let's say I have this line, which coincidentally is flat. It is parallel to the ground, essentially. And then I have this line that cuts across it. So the line that cuts across something we call a traversal. We'll come across that terminology later. So this is a, no, stop doing weird things. Okay, uh, this is a traversal. Okay, cool. So let's say I have this angle is theta. You'll notice a lot when we do geometry, we'll call angles like Greek letters, so theta, alpha, beta, those kinds of things. This is very good when you start taking more advanced classes because you'll definitely start seeing more of these Greek letters. So let's say this is angle theta. Can you guys tell me? I'll use blue because it was requested. Can you guys tell me what this angle is? What is this angle? Yeah, it is 180 minus theta. Oh, okay. So hold on. Let me write out how theta is because I may be pronouncing it weird. So theta is this. Theta. So we say theta. Theta. Yeah. Okay, awesome. So this stuff is 180 minus theta. All right. So based on that, can you guys tell me what this angle is? Okay, I do see a lot of like stuff in the chat that is not really like super related. I like that you guys are connecting. But let's keep this for like before or after classes. If you guys could kind of like maybe tone down the side conversations for now, that would be really great. And let's turn our attention towards the screen. Okay, thank you guys. Cool. All right, so I'm starting to get some answers from Urav and Rohan. Thank you guys, and Minnie and Aradhya. Awesome. So this is theta as well. And the reason why that is because if you look, I probably should have drawn the lines in different colors. That is something that I did not consider. Here, I'll make up for it now. If we look at this red line, we know this angle is theta over here. So because by supplementary angles, this angle in blue must be 180 minus theta. Now, if we look at the green line, we know one of the angles, and because once again they're supplementary, this red angle on this downside is also going to be theta. So very simple proof to show that this is correct. I do have one question from someone. Is it like an acute angle intersecting a line? Yeah, well, vertical angles don't have to be acute because technically this is an obtuse angle, and this is also a vertical angle to 180 minus theta. So yeah, these are very similar. These are both vertical angles. Okay, I have someone asking, Dorothy says, is theta like pi? No. So pi has a value. Pi is like 3.14 and some other digits. Theta is a variable. So yeah, theta does not represent a value. No, that's correct. Okay, cool. Glad we cleared that up. All right. So now that we have talked about vertical angles, we can talk about corresponding angles. And for this, oh, okay. Actually, I do see one more question. Tanish says, why do we use theta? It's kind of just like the default for an angle. You'll see lots of other Greek letters. Like you'll see something like this. This is phi. You'll see what else is there? Oh, you'll see like this. This is like omega. You'll see alpha. Like you'll see lots of letters. Mathematicians just tend to start off with theta for some reason and kind of work from there. But yeah. Okay, cool, cool, cool. You can use whatever Greek letters you like. Greek letters are cool though. Dorothy says, so like how we use x in algebra and angles, it's Greek. Yeah, yeah, that's a really good way to put it. Yeah, so if we don't know like an angle or something in geometry, we'll put a Greek letter for it. Yes, that's a really great way to say this. Tini says, are all these used in geometry? Yeah, actually, sometimes you can see all of these Greek letters in one problem, which means you are dealing with a beastly problem, but it is totally possible to see all of these letters in one problem. Yeah, so Arjun says they are all just variables, which is absolutely correct. Yes, yes. Maybe I should have specified that before. That is my bad, you guys. Let's see. Hithart says, I've once seen Omega in Mathly, but IDK what it is. Yeah, that's totally cool. It's just like a cool little symbol that looks like this, like a horseshoe. Okay, yay, we are all on the same page. Thank you guys for that great question. Good sidebar. All right, let's turn our attention back to corresponding angles. And now I'm going to introduce a fancy schmancy diagram because I think it'll be much easier to talk about. I'm going to clear all this up for now. I'm going to get some space to write. Okay, let's do blue. I know someone requested blue. I'll do light blue now. Corresponding angles. Okay, cool. Um, Here we go. Let's take a look. I think someone like mentioned this before. Oh no, technical difficulties. Okay, someone mentioned this before. Someone was mentioning or talking about how corresponding angles had some parallel lines and things involved, which I absolutely agree with. So, corresponding angles are really related to a diagram that looks like this, the stuff that's on my screen. So you have two parallel lines, and then you'll have something called a traversal, which I did mention before, actually. So a traversal is something that cuts across parallel lines. It traverses the lines. It's very easy to think about. So parallel corresponding angles seem very odd, but they are very, very intuitive to understand. And the way that is um, let's start off here. Let's say I have angle 1. If I start off here, we'll say, let's do a Greek letter. Mm, hmm. Let's do let's do beta. We'll start with B, because why not? So this, we'll say angle 1 is beta degrees. So can you guys tell me what angle 2 is in terms of angle 1? What is angle 2 in terms of angle 1? Think about like their relationship. Oh, okay, perfect. Yeah, so it's 180 minus beta. I did see some people put in a numerical answer. Remember, we don't know what beta is, so we can't say any number. We can just write other angles in terms of beta. Cool. Can anyone tell me what angle number 3 is? What is angle number 3? Yeah, it's also 180 minus beta. Okay, very cool. What about angle number 4? What is that? Yeah, it's just beta. That is absolutely correct. Okay, wow, my handwriting is atrocious, so if you can't read anything, please do let me know, and we'll fix that. Okay, can you guys maybe take a guess? What do you think angle number 5 is? Yeah, it is also beta. Okay, very good. I'm glad we are all on the same page here. Um, what about angle number 6? Okay, 180 minus beta. And then by now I'm sure you've noticed pattern, so I'll go ahead and fill out the rest. Oh, so this is also 180 minus beta. And this is beta. Okay, so you must be wondering, why is angle 1 equal to angle 4 equal to angle 5 equal to angle 8? The reason why that is because corresponding angles are basically in the same positions relative to the transversal and parallel lines. So kind of like to explain that, because that's a lot of weird random words strung together. Essentially what we're doing is parallel lines do not intersect ever, meaning that they are always at the same angle. So if I hold my arms like this to frame my face, these are parallel. They will never ever intersect, meaning that they don't have any angles, or they're not angled. Their angles are the same. So their slopes are the same. We'll kind of get to that. Um, but yeah, so they are always like parallel, never intersect. That's the definition of parallel lines. So when I have a traversal that cuts across it, it will make the same angles with both lines because they won't intercept. All you're basically doing is you're moving one line, the top line, down to another place. But because you're not changing how the lines are tilted or how they are related to each other, the angles are the same. So there's no like mathematical way to show this. It's more of like an intuitive understanding of parallel lines. So when you have two parallel lines, just to rephrase, we have the traversal cutting across, right? Let's say I'm looking at line 1 over here. We'll use like a yellow. I have this line 1, right? All I'm going to do is shift this down. And because I haven't tilted the traversal and I haven't tilted line 1, my angles are going to stay the exact same. Does that make sense? Let's see if we have questions. Okay, I think that makes sense. I do have a couple of questions about like where some of these angles came from. So let's quickly recap that. We defined angle one as beta. We don't know what angle one is, so we're just gonna say it's beta. Now we can find angle two because we know angle one and angle two are supplementary. They form line one. So because of that, supplementary angles sum to 180 degrees. That means angle two is gonna be 180 minus beta. So that's how we get angle 2. And then by similar reasoning, angle 2 and angle 4 are supplementary angles because they also form that line. So then we have 180 minus 180 minus b. So that gets us beta again. And then we kind of just go back. Uh, okay, awesome. So hopefully that clarified for everyone. Yeah, so supplementary angles basically are ones that forms lines. So if you see a straight line, and you see something kind of cutting it in half or kind of intersecting it, then you see supplementary angles because those sum to 180. Okay, cool. Uh, Great. I think we're all good. Okay, I'm glad we're all on the same page. Um, yes. Sorry, I am thinking about where I want to go from now. That's why I keep saying yeah, okay, all right. This is good, this is good. Okay, let's talk about exterior angles now. So corresponding angles, it's kind of hard to define, but it's very much easy to show in a picture. That's why we get this gigantic thing up here. So let's bring up exterior angles, which is kind of different from all the other ones we've talked about because exterior angles start dealing with actual shapes. So up until now, we've been talking about kind of like just lines and points and things. So now we're going to talk about real shapes. So exterior angles you will often see in polygons. So I'm going to draw, actually, I don't need to draw because I have a nice diagram with me. So let us use this very nice diagram. Okay, there we go. Can you guys maybe hedge a guess? What do you think the exterior angle is in this case? Oh wait, actually, hold on. You guys probably don't know what half of these symbols mean. Okay, let's change this into symbols you guys are familiar with. Um, we'll say this is we'll say this is theta, and we'll say this is omega. So which one do you think is the right exterior, or which one is the exterior angle? Okay, yeah, omega. Perfect, perfect. Oh, and it seems like we're already getting some guesses about what omega could be. Very interesting. All right, so omega is actually going to be our exterior angle, and I think this is pretty intuitive because it's on the outside of the triangle. So yes, this is our exterior angle. Okay, lovely. So how do we show what the value is? Because I do see some people hypothesizing that it is beta plus alpha, which is very cool. So we're gonna kind of like jump the gun a little bit. We're gonna kind of jump ahead, and we're gonna talk about the angles in a triangle. I think I'm not worried about this because I think most of you guys are aware that the sum of the angles in a triangle is 180 degrees. We'll explain later why this is true, but for now, if you don't know why it is 180 degrees, that's okay. Just know that it is. So this is 180 degrees. So how can we find theta in terms of the other angles in the triangle? What do you guys think? Give you guys a second. Let's see what you guys are saying in the chat. Let's catch up. Okay. Um, cool. Why do you smile so much even when you talk normally? I don't know, actually. This is just like, I don't know. This is just how I talk. But yeah, this is just, I guess, how my face works. Cool. Um, all right, seems like we're getting some answers from Anvika and Rob, which is awesome. So it seems like they are saying we can write theta as alpha plus beta, which I really, or sorry, 180 minus alpha plus beta, which I really like. Oh no, my diagram is like kind of cut off. Okay, there we go. We can say that beta plus alpha plus beta is 180. Remember, that's because all the angles in a triangle sum to 180 degrees. So I can write beta as 180 minus alpha minus beta. But theta and omega are supplementary angles because they make up a straight line. So that means theta plus omega is 180. But we can substitute theta. We know what theta is. So then we'll say that omega is equal to 180 minus theta, which happens to be alpha. Oh no, that alpha is horrible. Plus beta. Okay, very cool. So what you guys have just proved to me is some very basic angle chasing. Wow. Angle chasing gets a bad rep because people are like, oh my God, this is complex, or oh my gosh, I'm just going in circles and finding the same exact angles that I already knew. But there are some strategies that can definitely make the concept a little simpler, the idea a little simpler. So this is like the very basis of what we call angle chasing, which is the idea of finding angles that we don't know using the few angles that we do know. It's like the geometry equivalent of systems of equations, is how I like to think about it. So yeah, if you like how systems of equations work, but you don't like all the letters and stuff, and you like pictures, this will maybe be more your thing. All right, so by the exterior angle property, we can say that this omega down here is equal to alpha plus beta. We don't even need to do all this work. We can just look straight up here and say, okay, this is going to be the sum of these two angles that it's not adjacent to. All right, awesome. So let's kind of now talk about some triangles. I really hope we can get to at least one angle chasing problem because I would like to apply everything we've learned. So I'm gonna maybe go a little fast because I think you guys are pretty good with triangles at this point in your lives. So let's kind of actually I'm gonna leave. No, wait. Yeah, I think I'm gonna have to move all of this. Okay, that's fine. Because I want to make space for our angle chasing. Yes, Hittard says triangles are cool. Triangles are cool. They are the foundation of geometry. They are everywhere. Yes, triangles are very cool. So let's talk about triangles. So a triangle, very obviously, is a polygon with three sides and three angles. Very nice. The sum of the interior angles is always 180 degrees. Always, always, always 180 degrees. I mentioned this beforehand, just saying it now. We'll talk later why this is true, if you're curious, because we can actually show why it's true. For now, you can take it for granted. Take it for granted. Okay, so let's talk about the different types of triangles. Can you guys define a scalene triangle? What is a scalene triangle? What do you guys think? Yeah, sides are all different lengths. Good. So if the sides are all different, I'm gonna abbreviate different as DIFF. That also means that the angles are all different. You can't have two angles that are the same and then two sides that are also different. The reason why that is because angles correspond to sides. So if we have, and this is kind of like the basis of trigonometry. Wow, we are covering lots of cool things today. Angles relate to sides, and if you have two angles that are the same, sides must be the same, corresponding to those angles. Okay, awesome. So if all sides are different, all angles have to be different. That is a true property. What about isosceles triangles? Wait, I always get messed up on how to spell this. This is very difficult for me. Isosceles. Okay, very good. Yay, I think I got it. Okay. Yeah, two sides are the same. Two sides are same. And that means two angles are also the same. Two angles are the same. Yeah, very good. I am starting to see some cool vocabulary pop up. First of all, a lot of people are saying the word congruent, which I think is awesome. If you don't know what congruent is, do not fear. We will talk about that in the class. And now I also see some people asking if I know what sine, cosine, and tan are, and I do. And potentially we will talk about it. It just depends. But yes, do not fear if you also don't know what those things are, because they are very complex things, in my opinion. All right, and finally, what are equilateral triangles? All sides are equal. It seems like Cypress just like knew what I was gonna say, like had his answer already queued up. I think that's awesome. So three sides Oh, he is shaking his head no. He's just a really fast typer. That's awesome. Are same and three angles are same. Okay, excellent. Cool. Don't think I need to spend a lot of time here. Seems like you guys have a great grasp on this, which is amazing. Oh, actually, what is each of the angles in an equilateral triangle? What is the angle measure? Yeah, it's 60 degrees. Okay, good. Glad we're on the same page. That's because the sum of the angles in an equilateral triangle is 180 degrees, and they are all equal, so that means they each have to be the same, meaning they each have to be 180 divided by 3 or 60 degrees. Okay, great. If you felt like that was very fast, I apologize. I think you guys know this, so I don't want to waste time on it because I think there's more interesting problems, which we are now going to get to. Let's do some angle chasing. I saw some people asking, is the homework going to be long slash hard? I will say, compared to previous classes, probably not as long, just because it is a little hard to make all these diagrams. So maybe it'll still be challenging though, which is good. Challenges is good. All right, angle chasing, yay! Let's spend a couple seconds looking at this problem, and see if you guys can tell me what is the angle in the question mark. If this past few minutes have felt really rushed for you, shoot me a question, stay after class for any help, shoot me an email after class if you find a question later, or watch the recording. Yes, so you have 4 different options. Hopefully they all help. Okay, yay, we are getting some answers, and it seems like people are saying 50 degrees. Okay, very cool. Let's see why that is. Why is it 50 degrees? Oh, you know what? I feel like I've done a lot of talking. I need to drink some water, actually. So let's get someone to explain. Wow, seems like we have a hand raise from Manit. Okay, Manit, go ahead.
So, as you can see, it says AB is equal to AC. So we know that the the angle AB would be the same as the angle of AC, and we know that it's a horizontal line. So the 3 angles add up to 180. So we can do 180 minus 80, which equals 100, and then divide that by 2.
Oh, I really like this. Okay, very clever. Thank you, Manit, for unmuting and sharing. Did anyone want to add something? Did anyone like do this maybe a different way or had some different ideas? If yes, feel free to raise your hand so I can ask you to unmute and you can share. I think it's really great to see lots of different ideas, just because a lot of these questions can be done in many ways. Maybe not this one in particular, but definitely in the future, there will be lots of different ways to do things. Okay, let's take a look at this question. So first of all, thank you, Nunit, for explaining very well. Yeah, so we know this is an isosceles triangle. We can go ahead and find out what angle ABC is. That's going to be 50 degrees, and this is also ACB is going to be 50 degrees as well. You'll notice the way I say the letters is important for denoting the angles. If I say ABC, that reforms to the angle that is formed at point B by the lines with AB and BC. So yeah, just a clarification. And because they are similar, we can actually do a cool little thing here. If maybe you were a little confused by where Monique got some of the numbers from, or why he was able to say some of the things he did, let's do something cool. Let's extend this line this way. Actually, let's just extend this first line. Okay, so I know that this angle down here is 80 degrees. And actually, I can say something about this angle over here. I can say that it's 50 because it's going to be congruent to the angle down here. It's going to be equal to this angle down here. So that's how I can say this is 50. And by similar reasoning, because this is isosceles, I can also say that this angle is going to be 50 as well. So very nice problem here that is simplified by a lot of similar angles and equal angles. Yes, and also the 3 angles are supplementary. Yes, I like what Envika says about that. Because the 3 angles are supplementary, we are able to understand that they must add up to 180. And the isosceles triangle underneath that tells us that it has to be split off in a 1-to-1 ratio. That means they have to be equal. Okay, perfect. The question mark angle is external. Yes, so you can actually use a similar tactic as to what we did before. Yes, perfect. So many great ideas. Thank you, Envika, for putting that in chat. I really like that. Okay, great. So not a super difficult question. If you do have any problems with that or something is off to you, let us know in chat. And let's do one final question to end for tonight. This is like low-key a three-part question. That's okay though. We will still approach it. All right, so you actually have to find three different angles here, but let's start off going one by one. Can you guys find, hold on. Can you guys find this first angle for me? What is this angle? Oh, actually, I don't want to start off with that one. I want to start off with this one. What is this angle? Oh, it seems like you guys have already got the top angle though, so I guess I'll write it. Yeah, so no, you guys are all good. That was my fault. I changed my mind. I'm indecisive. Okay, so some people are saying this top angle is 60. Cool, cool, cool. We will come back to why it is 60. What about this bottom angle? Well, actually, I guess you can do that now. Yeah, so you guys see triangle ABE, right? We know triangle ABE has all the degrees summing up to 180. We see this angle down here is 50 and this is 30. That means the total angle A has to be 100 degrees. Now we know angle A does have a 20-degree portion and a 20-degree portion here. So that means this middle angle, the stuff in red, has to be the stuff that adds up to 100. So 100 minus 20 is 60. That's going to be this one over here. Okay, awesome. Can someone tell me what the green angle over here is? Maybe a hand raise. Let's call on someone who has not spoken yet. Wow, I see Manith again. Maybe I'll call on Amari. Amari, would you like to share why maybe you got this bottom angle is 50? It's okay if you can't. Just curious to hear your thoughts. Okay, no worries at all. No worries at all. I see you're a little hesitant. That's totally okay. No, good. All good, all good. Aditya, what about you?
So angle E, like AED is 30 degrees, and angle DAE is 20 degrees. And we know that all angles in a triangle have to add up to 180. So we can do 180 minus 20 plus 30, which is 180 minus 50. Which will give us that angle
Brush and go to bed.
is 130.
Very good, yeah.
And then that so this angle is 50.
Brush and go to bed for story
Yeah,
time.
that is perfect. Okay, really great work. And then, yeah, and actually a faster way you can do this is notice that this is technically an external angle. So you can actually just add up 20 and 30 and get to 50 here. And finally, I see Anvika's hand is raised. So Anvika, can you tell me how you got the final angle? Right here. Oh, mic is not working. Okay, that's totally okay. Well, let's finish this off together because I know we're a little over time. There's multiple ways we can find this angle. I'm going to do the simplest one. We see triangle ACD, which has total sum of 180 degrees, minus 60 degrees for angle A, minus 50 degrees for angle D, which I think is what Envika is putting in chat. And that comes out to be 70 degrees for the blue angle here. And we have finished this question. So I know that was super fast. But yes, okay, let's conclude really quickly. Thank you all so much for a really wonderful class. I hope you had as much fun as I did, and hopefully you learned a little something new. I hope this was different from some of the other classes you have taken. If you have questions, feel free to contact me. Feel free to stay after class to ask something. And yeah, look out for the homework and the recordings. We will put that up soon. And yes, okay, perfect. Thank you so much. Bye. Dorothy, awesome. Yes, you feel free to stay and we can talk further because I didn't really get a chance to really get into your question. Okay, perfect. Oh, Tanish, sorry, what was your question? Can you put your question back in? Oh, Anvika says, were you in my school? I went to South Forsyth Middle School, so maybe. Cool, cool, cool. Oh, Amari, no worries at all. I totally understand. Hopefully by the end of class, we can kind of build that confidence. You seem to be very, very good at these math problems, which is really great. So I would love to hear you share one day, but no worries at all. I know it's our first day, so don't feel too bad at all. No, I totally understand. Thank you for letting me know though. Awesome. Oh, Tanisha asked, were you on level, advanced, or accelerate? So it's very complex. This will lead to a very long story, but the simple answer is that I was in accelerated math. Yes. Cool. Okay. I know Dorothy had a question. Dorothy, I'm gonna ask you to unmute just so we can chat a little bit. I'll go ahead and stop the recording so this won't go out. Cool.